Hey guys, Bugcat7 here. Okay, it is Friday, December 20th, 2019, and I want to thank you for visiting the Stonewall Research channel here on YouTube. Thank you very much. I really do appreciate it. Alright, gang. Well, today we're going to talk about something related to the research that I do here on this channel about the quote unquote giants or large hominids, as I like to call them. Apparently, this large species of the genus Homo that we don't know anything about. And, mainstream science has very infantile euphemisms for it, such as, slightly more robust or anomalous or whatever it is. No serious study has ever been done of this stuff and sort of dismissed. They talk about these people, they talk about that they were large, but no explanation or anything like that. Okay, and apparently from our research here on this channel as we go state by state looking at the quote unquote giants, we keep on hearing about the larger and larger sized ones, beyond the 7 foot tall, 8 and 9 feet tall, 11 and 12 feet tall, even up to 18 feet tall. So, this only tells me there seems to be some sort of devolution going on from the oldest skeletal remains seeming to be these larger ones in these um, special types of burials, such as that in gravel, for instance, and in these vaults and, stone cut vaults, etc., etc. So, it seems to be that these race of the Homo genus that we don't know anything about, and what's the explanation for it? And I always keep on going back, and you'll hear me say on my channel often that the gravity was different, that there wasn't any ice age because certain events happened that mimic what they say is the ice age, but in reality was something else. And species of animals that must have undergone a very quick metamorphosis in evolution to come to the present day animals because they had counterparts in the late Pleistocene and early Holocene that, very different from them, but yet we still have those animals. And I often say on my channel about how the Americas were, particularly destroyed above and beyond anywhere else on the planet. And people hear these things, and I guess they say, well, where does he get all this stuff from anyway? And maybe we can go through it with this, believe it or not, when we're looking at the gravitational biology, because, you think the gravitational biology has a lot to do with it. And I have a video on my channel, which is a repost. I don't have a lot of reposts on my channel, but this is one of them, okay, by this fellow Stephen Hurrell from Britain. Okay, very intelligent guy, and he wrote a book about it. And here's one of the videos. I'll leave a link to it at the end of this video. I think you should take a look at it. Ancient Life's Gravity and Its Implications for Expanding Earth. He's an expanding Earth guy, and so am I, so uh, he explains expanding Earth in whatever way he explains expanding Earth, but I have a notion of how it happened myself. And you can even take some of the biblical accounts and other accounts from other civilizations to be evidence of this. But that's one thing here with this video. I think you should watch it. If you haven't seen it on my channel, you really should. And you'd be very interested into what Stephen has to say. So I believe in expanding Earth. And it's very interesting to me that Rupert Sheldrake here did this TEDx talk, okay, and it was banned. And this was about his book, The Science Delusion, all right? And in this lecture he's giving here at TEDx that they banned, okay, this is one of the things that drew me to this fellow, when I heard this was a banned TEDx talk. Well, I want to know what they're banning. Okay, that doesn't seem to be any sort of freedom of the press or anything like that to me. If you're banning stuff, I mean, what are they afraid of? It's nonsense. So, don't do my thinking for me. So let's just hear what Rupert Sheldrake has to say. He has, big credentials. It's very hard to, dismiss what he has to say. He has access to all these academic places and whatnot. And in this lecture, he goes over how he went to the head metrologist that measures the scientific constants and all this kind of stuff. So he was talking about the speed of light with the guy and how it changes. And the guy was like, "Oh, that's an embarrassing episode." And, he said, "Well, what if the speed of light really is changing and some evidence of it that it is?" And, they just fix it by setting it as a constant when it really isn't constant. So let's just hear what he has to say about gravity.
But I said, well, then what about big G, the gravitational constant, known in the trade as big G, it's written with a capital G, Newton's universal gravitational constant. That's varied by more than 1.3% in recent years. And it seems to vary from place to place and from time to time. And he said, oh, well, those are just errors. And unfortunately, there are quite big errors with big G. So I said, well, what if it's really changing? I mean, perhaps it is really changing. And then I looked at how they do it. What happens is they measure it in different labs. They get different values on different days, and then they average them. And then other labs around the world do the same, and they come out usually with a rather different average. And then the International Committee on Metrology meets every 10 years or so and average the ones from labs around the world to come up with the value of big G. But what if G were actually fluctuating? What if it changed? There's already evidence, actually, that it changes throughout the day and throughout the year. What if the Earth, as it moves through the galactic environment, went through patches of dark matter or other environmental factors that could alter it? Maybe they all change together. What if these errors are going up together and down together? For more than 10 years, I've been trying to persuade metrologists to look at the raw data. In fact, I'm now trying to persuade them to put it online on the internet with the dates and the actual measurements and see if they're correlated, to see if they're all up at one time, all down at another. If so, they might be fluctuating together, and that would tell us something very, very interesting. But no one has done this. They haven't done it because G is a constant. There's no point looking for changes. You see, here's a very simple example of where a dogmatic assumption actually inhibits inquiry. I myself think that the constants may vary quite considerably, within narrow limits, but they may all be varying. And I think the day will come when scientific journals like Nature have a weekly report on the constants, like stock market reports in newspapers. This week big G was slightly up, the charge on the electron was down, the speed of light held steady, and so on. That's one area, just one area where I think.
So anyway, you get the gist of what he's saying. Gravity, the data on gravity shows that it's moving around and going all over the place. It's not constant. So there are these constants that aren't constant. So just keep that in mind when we're talking about gravity. So, why would I think that the Earth would expand? Well, let's look at the Earth, okay? So it's a giant ball of iron inside the Earth at the core, right? A solid iron core, right? With a liquid outer core and sort of like a trans section of this sort of mantle and a crust, right? So if I took a mylar balloon, I took an iron ball on a rod and put it like a mylar balloon on it and then hit it with electrical current, what do you think would happen to that mylar balloon? Well, I bet you 9 out of 10 times the balloon's gonna expand, okay? Because iron's a good conductor, and according to Velikovsky, who wrote this book, Earth in Upheaval, he's talking about something different from the Ice Age, all right? That the Ice Age never happened. And what actually happened was this. See, so if the Earth has an iron core, a solid iron core, and this kind of arcing was going on, okay, it might cause expansion. And during this expansion, the water that was inside of the Earth might come out of the Earth when this event might happen, like what it says in the Bible, right? The water came out of the earth, okay? And I always say North America was hammered, right? So let's look at what a Lichtenberg figure looks like, okay? That's what these patterns are here, Lichtenberg figures. That's in like a resin. And let's just look down here. They show somebody with got it on their foot from getting hit with lightning. It's a high voltage discharge, right? Looks like blood vessels almost, but more jaggedy looking. And let's take a look at this. Lichtenberg branching figure in leopard wood. Okay, so you see what that looks like, right? So let's look at this. You see this? See anything familiar there? Looking? Okay, well, that's the Grand Canyon, folks. It's a giant Lichtenberg figure. Alright? If that's not evidence enough for you, I don't know what is, okay? There are many places where you can see these types of things on the earth, okay? But this is in North America, right? So can anything corroborate that? Yeah, I think so. And we're going to talk about that as far as the Pleistocene extinctions, the the megafauna, okay, when they went extinct, etc. But let's take a quick look at gravitational biology. It's just real short here. Gravitational biology is the study of the effects of gravity. Of the effects gravity has on living organisms. Throughout the history of the Earth, life has evolved to survive changing conditions such as changes in the climate and habitat. However, one constant factor in evolution since life first began on Earth is the force of gravity. So they say, okay? It's a theory. As a consequence, all biological processes and accustomed are accustomed to the ever-present force of gravity, and even small variations in this force can have significant impact on the health and function of the system of organisms. So you see that right there, all right? No mystery there, right? So small variations in this force can have significant impact. Just small ones, okay? The force of gravity on the surface of the Earth, normally denoted G, has remained constant in both direction and magnitude since the formation of the planet. As a result, both plant and animal life have evolved to rely upon and cope with it in various ways. So, That's not true. So you can forget about that. Gravity's bouncing around all over the place, and if the planet was smaller and then suddenly got bigger, and the whole magnetic field was altered, and gravity is an electrical process. It's a result of electrical processes. That's how gravity. Electricity is the strongest force, okay? As we know from Velikovsky and the Thunderbolts project. This is taken from the Thunderbolts project, right? Thunderbolts, all right? Velikovsky's work, all right? Lichtenberg figures, the Grand Canyon, all right? So plant tropisms, plant use of gravity. Plant tropisms are directional movements of a plant with respect to a directional stimulus. One such tropism is gravitropism, or the growth of movement of a plant with respect to gravity. Plant roots grow toward the pull of gravity and away from sunlight, and shoots and stems grow against the pull of gravity and towards sunlight. And that's why they have to have rigid, they have to be rigid. Plants have to be rigid in order to stand up straight and get all the sun with their branches, which are also like Lichtenberg figures. Animal struggles with gravity. Gravity has an effect on the development of animal life since the first single-celled organism. The size of single biological cells is inversely proportional to the strength of the gravitational field exerted on the cell. That is, in stronger gravitational fields, the size of cells decreases, and in weaker gravitational fields, the size of cells increases. Gravity is thus a limiting factor in the growth of individual cells. Okay, so I'm not going to read any more on this, it's unnecessary, but you see right there, the stronger the field, the size of the cell decreases. The weaker the field, the size of the cells grow. Okay, so they could always never figure out, and this is why Stephen Hurrell goes over this, they could never figure out why the dinosaurs could be so big. They couldn't be so big in our present gravity because their sheer weight and size would just keep them, unable to be graceful animals and walk and do anything really. They don't know what kept them up, so they have all these theories that it might have been a different gravitational field or oxygen. They don't know, they just don't know. So Stephen Hurrell tries to explain it with its implications of the expanding earth, okay? And like I said, this, it's a giant iron ball in the middle of the planet. If something like this happened, what do you think would happen to the giant ball that's inside? It would get superheated. The core of the planet would get superheated, okay? And it's showing, I think, Mars and Earth, because they believe Mars and Earth. They're always finding meteorites from Mars, and they can never figure out why. Mars has this giant scar on it. They don't know where the scar came from. Well, they're saying it's this. Okay? And let me just read quickly because I'm going to run out of time here, but the late Pleistocene extinctions. Approximately 11,000 years ago, a variety of animals went extinct across North America. These were mostly mammals larger than approximately 44 kilograms, about 100 pounds. Some of the animals went extinct are well known, like saber-toothed cats, mammoths, and mastodons. Others are less well-known animals, like the short-faced skunk and giant beaver. Some animals went extinct in North America, but survived elsewhere. For example, horses and tapirs. So you notice that these things survived elsewhere in the world, but not there. Okay. Before this extinction, the diversity of large mammals in North America was similar to that of modern Africa. As a result of the extinction, relatively few large mammals are now found in North America. Why did these animals go extinct? The real answer, okay, is that scientists do not know for sure. This is the Illinois State Museum. This is an active area of research for several paleontologists at the ISM and for many scientists in other institutions. Scientists who study the extinction have identified three major mechanisms that may have caused the extinction. These three causes are Okay, so you're going to say man, over hunting, over predation by mankind, secondary predation, all this kind of stuff. But meanwhile, Chuck just went over on his channel. I read the same exact article that he read, or a copy of that article or whatever, about how just recently, okay, they found out that many of these extinctions happened well before they can attribute it to human causes. Okay, so that's not quite right either, and I think they mention it in these Wikipedia articles and whatnot. But just to get back to why I say North and South America were hammered in other places, I'd love to read this whole article for you. They go into the hyper disease, all this other stuff. So let me just read the little end part of this to you, just to show you, okay? North America is not the only continent which experienced an extinction of this kind near the end of the Pleistocene. In South America, most of the species of medium to large animals also went extinct approximately 11,500 years ago. So this is how the Americas were hammered by this thing, whatever happened. In Australia, a major extinction also occurred. The timing of this extinction is much more poorly known, however. It appears to date between 40 and 24,000 years ago, so we're not talking about the same time period. Europe, Asia, and Africa also experienced some extinction toward the end of the Pleistocene when this event happened, and then these very large animals couldn't cope with the new gravity. However, on all of these continents, the extinction was less severe. Few species involved. So it was most severe in North and South America. So human beings have been around a lot longer than this, okay? And now their dates for the Bering Strait crossing go beyond 11,500 years ago. Do they even know what they're talking about at all? I don't think they do. Okay, they just jumping all over the place, and we can't get honed in on when these events actually occur and what they were. But they always talk about the Ice Age, which is a 200-year-old theory by Louis Agassiz, a Swiss American who was supposedly a geologist at a time where geology hadn't been a fully developed discipline. So, they stick with that theory no matter what, and they had to